Ifra, am I audible? Rumaisa, am I audible? The setting to the setting for the participants to unmute themselves is already on. So I don't know why you're facing a problem with that. You should not be facing a problem with unmuting yourself. As for Yatika, am I audible? Am I audible, Yatika? Can you hear me? Am I audible now?
Yes, ma'am.
Okay. Please take out the book, or if you don't have the book, please take out a PDF, because without a PDF of the book, without the textbook, you can't study, because we're doing exercises over here, right? And I have repeatedly mentioned it. You're supposed to have the textbook with you. And if you don't have the physical textbook, there is plenty of PDFs available on the internet of the NCERT. You can download it from there. So please read question number 5 of the same exercise we were doing last time, Yatika. Yes, I'm waiting. I have sent the PDF in the group chat, the meeting chat. Exercise 9.2, question number 5. Yes, I'll keep waiting for any of you to read the question.
Recording in progress.
Among the question 5, right? 9.2.
Yes, question 5, exercise 9.2 from the PDF.
Okay. So, three girls, Reshma, Salma, and Mandeep, are playing a game by standing on a circle of radius 5 meters drawn in a park. Reshma throws a ball to Salma, Salma to Mandeep, Mandeep to Reshma. If the distance between Reshma and Salma and between Salma and Mandeep is 6 meters each, what is the distance between Reshma and Mandeep?
Okay, thank you. So there is a circle of radius 5 meters as per the question. So the radius is 5 meters. So they are standing in such a way that the distance between Reshma and Salma and Mandeep is 6 meters each. So if this is Salma and if this is Reshma, this is Mandeep. Okay. So the distance between Reshma and Salma is 6 meters. So this line over here is 6 meters. And similarly, this line segment over here is also 6 meters. And the radius of the circle, let's say this is the center, and so this is 5 meters. The radius of the circle is 5 meters. They are asking what is the distance between Reshma and Mandeep. So they want to know this distance, RM. Okay, so the distance between each one will be Rm. To find Rm. Okay, now we can see that this one is an isosceles triangle. Which one? This RSM. Okay, this is an isosceles triangle. So let's do one thing. Let's connect these as well. Let's connect these. And let's connect this O and S. So the point where this meets the RM is P. Okay, so let's write it like this. So construction. So let's say R is Reshma, S is Salma, and M is Mandeep. Okay, that's why I've written these letters. And so construction, we are to draw OP, this one, perpendicular to RM. OP perpendicular to RM. This is the construction we have made. And let's make another construction here. Let's call this point as N. Okay, let's call this point as N. And ON perpendicular to RS, right? This is RS. So we have to find what? RM. So let RM be equal to X. The distance RM, let it be equal to X. Now, if you look at the area of triangle ORS, what is it going to be? Triangle ORS, this one. This triangle over here, what is the area going to be? We know that area of a triangle, if the height is given, it is half into base into height, right? What is base and height? Base of it is NS, right? NS, area of triangle O, oh sorry, not this one. ORS, this one. This triangle ORS. The smaller one is ONS, this triangle. So half into base into height. Base is what? RS, and height is what? ON, right? But this is also equal to this, if you want to look at it like this is a triangle. And if you look at this pink line as the height, if you look at the pink line as the height, that is also one of the heights. So in fact, first I'm going to write that one, and later on we will come to the second one. Okay. So area of triangle ORS is half into height, which in this case is RP, into OS, which is, if this is the, forget about ON for a while, if this is your height, then the corresponding base will be this one, OS. Okay. So half into RP into OS, which is equal to half into RP is how much? How much is RP?
Half of RM.
It is, yes, exactly. It is half of RM, right? So, which is, let's do one thing. Let's call RP as X, okay? Because otherwise you'll have to do X by 2 and there'll be some issues down the line. So let's call RP as X, then RM will become twice of X, right? This we will do later on. But right now, let's take RP as X. So fine. So half into X into OS. And OS is how much? How much is OS? OS is also a radius of the circle. So radius of the circle is 5. So this is equal to 5x by 2. So area of triangle ORS is 5x by 2. This we are going to keep in mind. Equation number 1. Now let's look at triangle, this other triangle, this one, RNO. Okay, area, not area, just in triangle RNO. It is a right angled triangle. So we can say that Rn square plus ON squared is equal to OR squared, right? In this right angle triangle. How? By Pythagoras theorem. So Rn squared is how much? It is 3, because we know that perpendicular from center to chord bisects the chord. Perpendicular is this blue line. Perpendicular from center to the chord RS bisects the chord. So that means Rn is going to be half of 6, which is 3. So 3 squared plus ON is how much? We don't know. Is equal to OR squared. OR is how much? 5. So now that means ON squared is equal to 5 squared minus 3 squared, which is 25 minus 9, which is 16. That means ON is equal to 4. This is one more thing. ON is equal to 4. Now, again, if you take area of triangle ORS, taking this time area of triangle ORS, this triangle, taking RS as base and ON as height. Okay, let's write it over here again. Area of triangle ORS is equal to half into base, which is RS, into height, which is ON. So what we're doing here, we are taking area of triangle ORS in two different ways. And why we are doing that, you will come to know. Okay. So half RS into ON. RS is how much? We know that it is 6. And ON we just now found. So it is 4. So 2 twos are 4, and that is 6 twos are 12. Okay. So that means area of triangle ORS is equal to 12. So now we can, so this is why I said first we will do it in this way. First we will take our P as height and OS as base. And then we will take this one, RS as base and ON as height. Because then in this case we didn't know ON. So now we can compare 1 and 2. From equation 1 and 2. They're both the same thing, right? Area of triangle ORS. They are both area of triangle ORS. So that means 5x by 2 is equal to 12. That means 5x is equal to 24 by 5, which is equal to, I'm sorry, x is equal to 24 by 5, right? And if x is 24 by 5, then what did we need to find? We needed to find Rm, which is equal to twice of x. This thing, Rp, this is x. And Rm is twice of x. So let's find Rm. Therefore, Rm is equal to twice of x, which is equal to 48 by 5. And if you calculate that, that's going to be 9.6 meters. Why in meters? Because the original, it was given in meters. Okay. So this is the value of Rm. Okay, please note this down. All right. So the next question is also pretty similar one, but it's actually a little bit longer. Let's do it. So question number 6. Yes, please read it out, someone. Question number 6. Please read it out.
A circular park of radius 20 meters is situated in a colony. Three boys, Ankur, Sayed, and David, are sitting at equal distances on its boundary, each having a toy telephone in his hands to talk to each other. Find the length of the string of each phone.
Okay. So they are sitting at an equal distance on its boundary, right? So equal distance. Let's make it like this. Acha, one more thing. See, when you draw, so let me just recap this for you guys. For equilateral triangles, this is an equilateral triangle, right? Because they're saying that the distance between each of these people is the same. The distance between them is the same. So that means each of them, each of these sides is the sides of an equilateral triangle. So for equilateral triangles, this happens that, first of all, for equilateral and isosceles triangles, altitude is the same as median. What is the difference between altitude and median? Let's see. So let's say if you have a triangle over here. If you drop a median from this point to the opposite side, median is that line segment which bisects the opposite side, okay? Which basically joins this point to the midpoint of the other side. So that is median. You can remember that, M for median, M for midpoint, okay? Altitude, however, altitude means height, okay? And height just means 90 degrees. It has to be perpendicular. So it so happens that the altitude and median of uh, an isosceles triangle and equilateral triangle, they happen to be the same. So if this is an isosceles triangle with these two sides same, and if you drop a perpendicular, then this perpendicular, this is an altitude because it is a perpendicular, and it also happens to be a median. This is something that I think you must have proved in your triangles chapter, but we just recapped it. So altitude and median is the same for equilateral and isosceles triangles. Now one more thing, for equilateral triangles, the point of intersection of all the three medians, okay? So let's say this is the midpoint of this side, this is the midpoint of this side, and this is the midpoint of this side. So the point of intersection of all the three medians, I have not drawn it well. Okay. The point of intersection of all the three medians, it happens to be the center of this circle. Okay. It happens to be the center of this circle. So this is one thing that you will need to remember for this question. Okay. In case this question comes in your exam, this is something that you need to remember. All right. So I'm just going to draw this in a better way now. Give me a minute. Okay. So let's call this point as O because it's the center of the circle. Okay. And so Ankur, Syed, and David are sitting here. So let's call this as Ankur, Syed, and David. All right. So what are we given? The radius is 20 meters. So if the radius is 20 meters, that means each of these OD, OA, and OS is 20, right? So OD, OS, and OA, each of these is 20 meters, basically. And since these are medians, that means they are altitudes also because they are medians of an equilateral triangle. And we just saw that medians of an equilateral triangle are altitudes as well. So now let's get started with the actual question. So construction was that we drew altitudes. Let's name these points something. Let's call this uh, uh, um let's call this P, Q, and R. No, P, Q, and R. Okay. Altitudes AP, SQ, and RD. Fine. Okay. Now let we need to find the what did we need to find? Find the length of the string of each phone. Okay. So we need to find the distance between A and S. So we need to find AS, SD, and AD. So let's call each of these as X. Let AS is equal to SD is equal to AD is equal to X. Okay. So this is what we have let. It is equal to X. All right. Next. So since these altitudes are medians, therefore, what happens is that SP is equal to PD, right? I hope I don't need to write it over here because this point is clear. Now, in right angle triangle, I'm just going to write in triangle APS. In triangle APS by Pythagoras theorem. By Pythagoras theorem, what do we have? In triangle APS. Triangle APS is this one. Okay. We have AS squared is equal to AP squared plus PS squared because this is a 90 degree, so it's a right angle triangle. So we have this equation. Now, how much is AS? AS is equal to how much is AX? AS, it is equal to X. We had let it equal to X. So AS is X. So X squared is equal to AP. How much is AP? We don't know yet. So it is AP squared plus PS squared. PS is how much? Remember, PS is half of PD, half of SD. PS is half of SD. And SD is equal to X. So half of X is X by 2 basically. So X by 2 whole squared. Why? Let's write it. Let me write the reason. Uh, since PS is equal to half of SD, which is equal to half of X. All right. So now let's continue with this equation which we've gotten. So let's bring the unknown to the other side. AP squared is equal to x squared minus x by 2 whole squared, which is equal to x squared minus x squared by 4, which is equal to 3x squared by 4. So that means AP square is 3x squared by 4. If you take the square root, if you take the square root of on both the sides, that means AP is equal to under root of this thing, which is equal to root 3 by 2x. Okay, so this is AP. AP, let's remember this. This is our AP. Okay, now we know that AP is actually equal to AO plus OP, right? And what is AO? It is the radius. AO is the radius, which is equal to 20. And OP is how much? We don't know. So let's keep that as OP itself. And AP is equal to root 3x by 2. So that means from here we can write that OP is equal to root 3x by 2 minus 20. So this is something that we're going to have to remember. So I'm just going to put it in a box here. Okay. Now this question has multiple steps. It has multiple things that you need to do in this. So for this question, you have to get a lot of practice. Okay. So OP is equal to root 3x by 2 minus 20. Okay. So now let's look at let's look at another triangle. This triangle, this one. Okay. Let's look at this triangle. Let me denote it with something else. Oops, sorry. OPS. So in triangle OPS. In triangle OPS, again, it's a right angled triangle. So again, we can take Pythagoras theorem here. By Pythagoras theorem, what is it going to be? It's going to be OS squared is equal to OP squared plus PS squared. So now OS squared. OS is how much? It is the radius. OS is the radius. So it is equal to 20. So 20 squared is equal to OP. Acha, OP we already have gotten this particular value of OP, root 3x by 2 minus 20 whole squared plus PS squared. PS squared. PS squared we don't know. Do we? Oh, we do know PS. PS is this, right? PS is half of x or x by 2. So x by 2 whole squared. Okay. So now 20 squared is how much? 400 is equal to, now you apply this formula a minus b whole squared. So you get root 3x by 2 whole squared plus 20 squared minus 2 times into b, which is root 3x into 20 or 20 root 3x. The 2 gets cancelled with the 2 which comes over here, 2 into a into b, right? So the 2 gets cancelled over there. Plus x by 2 whole squared is x squared by 4. So this becomes 400 is equal to 3x squared by 4 plus 400 minus 20 root 3x plus x squared by 4. So now let's club these things. 3x squared by 4 plus x squared by 4 is what? 4x squared by 4, which is nothing but x squared. So x squared, and this positive 400 get cancelled on both sides of the equation, right? It's the same as saying you subtract 400 from both sides of the equation. It's the same as that. Or if you want, you can say that we are sending this 400 to the other side, it becomes 0. So these both get cancelled. We have 0 left on the LHS. And we have minus 20 root 3x. Yeah. So now we can just, that basically means that x, you can take x as common over here. And then in the bracket, we have x remaining, x minus 20 root 3 is equal to how much? 0. So again, as in the previous class, or I think one of the previous classes, we had discussed that if you have two numbers a into b and their product is 0, then either a is 0 or b is 0. So here you have two things. What two things do we have? We have x and this bracket. So either x is 0 or x minus 20 root 3 is 0. But x can't be 0, right? Because x being 0 means that the distance between them, because x is this thing, right? The distance between each of the two kids. So that can't be 0, obviously. So therefore, x is not 0, but x can't be 0. We'll write it like this, but x can't be 0. Therefore, x minus 20 root 3 is 0. Or in other words, x is equal to 20 root 3. Okay, so x is equal to 20 root 3. We have found it out. X is equal to 20 root 3. And is that what we wanted to find? Yes, we wanted to find this thing. So that's the answer. I'm just going to go over this once again. I think the previous one was simpler than this, so we don't need to revise the previous one. But this one we will just recap. So what we did was we took two triangles. The first one we took was the bigger triangle. That was also a right angle triangle. We applied Pythagoras theorem. Okay, in the bigger triangle, we applied the Pythagoras theorem and we came to this. AP is equal to root 3 by 2x. Okay, and then after that, we also saw the fact that AP is AO plus OP. So that's why we wrote it like that, and then we got the value of OP. Whoops, it's a little problematic. Okay, then we got the value of OP. And then in the smaller triangle, the pink triangle, we applied the Pythagoras theorem. And from that, we just put the value of AP, we just put the value of OP, and we got the value of X from that. Okay. So you need to remember this, that you need to take two triangles. See over here, if you initially see, there are plenty of triangles. So you might get confused, which two triangles should I take? So it doesn't matter as long as you are taking the two triangles whose base is the same. Okay, so that at least you'll have something common. Like over here, we had SP as common, right? PS, we had PS as common. So we had here also, we put the value of PS, and here also we put the value of PS. So as long as you have something as common, you can take those two triangles. So take the two triangles which have the same base. All right, so please note this down. Okay, are you done? Shall we move forward? So next we are going to do a new theorem. If you recall, we had discussed what does it mean when we say angle subtended by an arc, right? See, if you have like a chord over here and it subtends an angle at this point P, you will say the angle subtended by the chord AB on or at point B. But in case you don't have the point, in case you don't have the segment, the line segment AB, the chord AB, then in that case you can just say the angle subtended by the arc AB. Okay. So angle subtended by arc or angle subtended by chord, you can say either of those two things. So the next theorem we're going to do is about angle subtended by an arc. So the theorem says angle, is it that right? Angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of the circle. So what does this mean? It means that if you take an arc, let's say this arc, I need to make it a little bit thicker. Okay, let's say you take this arc, the angle subtended by it at the center, this is O, is going to be double, meaning if you see this angle, and let's call it AB. So this angle over here, angle AOB, is going to be double the angle subtended by it at any point on the remaining part of the circle. What does it mean remaining part of the circle? Meaning any point apart from this pink portion. Okay, any point apart from the arc. Okay. So if you want to see this angle APB. Okay, so what it means is that angle AOB is twice of angle APB. Okay, angle AOB is twice of angle APB. Or this point P could be anywhere, it could be here also. Or let's call it a point Q. Then this angle that it subtends at Q is going to be half of the angle at this center, which is O. Okay, so angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of the circle. Okay, so let's do the theorem for this. Let's do the theorem. Let's remove the additional parts. To the proof. Okay, so first we will need a construction. Construction Let's name this point as, R. Okay. Now we have to join OR. Join OR and extend it to a point. PT means point S. So let's join OR and extend it to a point S. Could be anywhere. This point over here is S. Okay. Now look at this triangle. Look at the triangle ORA. In triangle ORA, we know that if you guys know about the angle sum property of a triangle, first let's make this as a chord. Okay. Not angle sum property, exterior angle property. Okay. Exterior angle property. Exterior angle property is basically if you have a triangle and this thing extends over here, then this angle over here, let's call it x, and these two angles are a and b, then x is equal to a plus b. That means the exterior angle is equal to the sum of the interior opposite angles. Interior opposite angles means interior angles, but not the adjacent one. Okay. This one, if I write this as C, this is adjacent to X. So we're not talking about C right now. We're talking about the angles which are away from X. So they are the interior angles, but away from X, so opposite angles. Okay. So exterior angle property says that exterior angle is equal to sum of the interior opposite angles. Okay. So in this triangle ORA, we can say that this angle over here, angle SOA, angle SOA is equal to the sum of the interior opposite angles. And what are the interior opposite angles? Not this one, this and this. Okay. So it is equal to the sum of, meaning equal to angle ORA plus angle RA.